Hey there, it's Jason Gorman from Codemanship with a video all about the principles of simple design for C# programmers. Simple design is a set of design goals or needs, courtesy of our friend Kent Beck, the person we most closely associate with test-driven development. And these are principles, guiding principles, if you like, that we apply to our code as a design emerges, starting with the most important quality of any software design, which is it's got to work. If it doesn't work, it doesn't matter how elegant or maintainable your design is. If it's the wrong thing or it doesn't do what the customer says, or specifically if it doesn't pass the tests, then it's the wrong design. So make sure that it works, make sure that it passes its tests, and make sure that it stays working. So keep running those tests after you make each change to the code. Provided your code works, the next thing we worry about is how easy the code is to understand. As Kent puts it, you want to make sure that your code clearly communicates its intent, that we can understand what the code does just by reading the code. So provided it works, provided the code is easy to understand, that it clearly communicates its intent, the next thing we worry about is how much duplication there is in the code. And the acronym here that we've heard before is DRY, don't repeat yourself. Two things about duplicate code. The first thing is from a maintainability point of view. If, for example, I copy and paste code like 5 or 6 times, and then I want to make a change to the common logic in that copied and pasted code, I've now multiplied the cost of making that change. So it is a barrier to changing code. It increases the cost of changing code. But also, more importantly, arguably, from a design point of view, duplication is very interesting because the opposite of duplication is reuse. And the abstractions, the reusable abstractions we introduce into code, like parameterized methods and classes and so on, if they're introduced through the process of removing duplication, they're more likely to be the right abstractions. Now, we've looked in a previous video at duplicate code, and we've talked a little bit about the rule of 3. That is, on average, we wait to see 3 examples of duplication before we refactor it, so that we don't jump in too early when we haven't really seen the pattern and introduce the wrong abstraction, but also that we don't leave it too late, that there's too much duplication, and now the cost of refactoring that would be too high, and therefore we're unlikely to actually do that refactoring. So make sure your code works and that it stays working. Make sure that the code clearly communicates its intent, that we can understand what the code does just by reading the code, and then remove duplication of code, bearing in mind the rule of 3, to introduce abstractions and to lower the cost of making changes. Now remember, this is a hierarchy of needs. So if in the process of removing some duplication, in the process of doing that refactoring, we find that we've actually made the code harder to understand, maybe it's just a bit too abstract, then we need to roll that back. So always review the code after you've refactored to remove duplication. Review the code after any of these refactorings just to make sure that it has actually improved it. And if it's made it harder to change, maybe you need to leave the duplication in. And finally, from where simple design gets its name, you want to make sure that the code you've written is the simplest thing you could have done to solve the problem, the simplest thing that would pass the tests. If you've got code in there that you could simplify or even delete and all your tests still pass, assuming, of course, that your tests are based on the original requirements, and that's an upcoming video, and then maybe you don't need it. So the acronym here is YAGNI, you ain't going to need it. Now, programmers, we tend to find this hard for all sorts of reasons. Number one, we do a lot of things by habit, and we're going to see an example of something I've done by habit, a habit that a lot of programmers are in. And I've added something to my code that nobody's actually asked for, but I've just done it because that's what I always do. But also, particularly when programmers are less experienced and have less confidence, we often feel that we have something to prove, and we prove ourselves by doing more sophisticated designs. It takes quite a lot of confidence sometimes to do the simplest thing possible. And we don't make it easy for each other. I've sat in code reviews where programmers have been berated for doing the simplest thing because it was just too obvious. So let's not beat each other over the head on this particular issue. Simple is beautiful and simple is difficult. Sometimes the simplest thing is the hardest thing to spot. So we need to start valuing that and not valuing our ability to do the heavy lifting. A good example of that is design patterns. So a lot of developers, and I'm exactly the same, when I first learned about design patterns in the mid-90s, I just used them everywhere. Factories and strategies and builders and you know what, because I could. And basically to prove that I knew them. It's a bit like, guitar players. There are guitar players who will play what the song needs, and then there are guitar players who will just play the most notes possible, the most scales, the most arpeggios. Let's cram as many notes as possible into this particular solo to prove that I can do it, to prove that I can do it. Now, I do that purely because I enjoy it. But from an artistic point of view, it's kind of bankrupt. And the same is true of code. That if you're just showing off, that's kind of bankrupt. You need to have the confidence to do the simplest thing possible, particularly when it comes to production code, because every level of complexity we add to our code costs money. It all costs money, not just to write that code in the first place, but 7 to 10 times as much to support it afterwards. So maybe you spent a day writing code you didn't really need. Some other poor soul might be spending a week or 2 weeks maintaining that code during the lifetime of that product. So what is the simplest thing you can do? You need to be quite brutal with yourself here. And you also need to have the confidence to do the simplest thing possible, no matter how easy it looks. Okay, so those are the principles of simple design. We're going to do a little demonstration now. So let's go look at some code. Now this code is on GitHub, so I will post a link in the description below. And it is our Mars rover. Hurrah, it's back. I bet you love it by now. Our Mars rover, it executes a sequence of instructions. That's a string of characters representing instructions to turn right, turn left, go forward or go back. And we can see here that I've done very little refactoring at all. There's all sorts of stuff in here that we might need to think about. So I've left some juicy refactorings to do here. First question, though, is the first box we need to tick is, does this actually work? So before I do any refactoring at all, let's run our tests. Make sure they're all passing. They are all passing because I checked before I started recording, but let's see again. Take nobody's word for it. Super duper, so it works. Question number 2, does it clearly communicate its intent? Can I understand, for example, what this block of code is doing just by reading that block of code? Well, no. If I hadn't written this, I think I might have a little problem with this. So what we can do is we can start extracting or introducing things that have names that describe what this block of code does. So we could, for example, extract a method. Let's extract a method. Let's call it right. So it's turning it to the right. You'll see there's going to be a bit of control flow shenanigans here because I put lots of return statements in. A good argument against not doing that, by the way. But that's fine. So it's done a little shenanigans there with this automated refactoring to maintain what it sees as the control flow of this particular part of the code. In actual fact, it's not needed, as we'll see. Yagni, you ain't going to need it. We don't need this. We can simply tell it to go right. And we'll prove that by rerunning the test. So I did not need that if statement in order to pass my test. So Yagni, there, it's gone. Let's just take a look at the implementation of the right method. There it is down at the bottom. So it's telling me in my clever IDE, Rider is telling me that that's not needed. So let's make that void. And you'll see that it's changed all those return statements to match. How jolly clever of it. Super duper. Okay. And a similar kind of thing here with our code for turning to the left. We could make that self-documenting, self-describing by extracting a method and calling that left. And you'll see it's done a similar thing with the control flow there. That's because I copied and pasted that code, which would be a bit of a hint that there's some duplication in there. Whenever I see people copying and pasting code, I immediately think, well, that's deliberate duplication. Okay. And of course, if there are any bugs in the copied and pasted code, you just copied and pasted the bugs as well. It's a bit like eating food you picked up off the street, copying and pasting code. And again, a similar thing here. We don't really need this. So Yagni, you ain't going to need it. Let's get rid of it. And super duper, and it's still working. So notice how often I'm rerunning those tests. Make sure don't just test it once, keep testing it, make sure it stays working. Okay, now there's a bunch more stuff I can do here. For example, this makes it go forward. This makes it go back. So we could make those self-documenting by introducing forward and back methods. No control flow issues here because there are no multiple return statements. So we can just do it. There we go, forward. And this one makes it go back. Again, this code all looks very, very copy and pasty, doesn't it? Naughty Jason. Okay. And back. So now we've got these methods, left, right, forward, back. So they're describing what these blocks of code are doing. So we've made sure that it works, and we've been constantly making sure that it stays working throughout. So we don't get too far from passing tests. Now let's take a look at these left and right methods. Let's look at the right method, for example. We move on from communicating intent to now to thinking about duplicate code. Now what I've got here is it looks like 3 examples of duplication, but if you think about it, actually it's 4. And I can prove that by introducing something that is logically equivalent to those other 3. So if we're facing west there, then we want to end up, I can just move that into there actually, facing north. And just to be absolutely explicit, I'm going to put in a redundant return there. So now what we've actually got is 4 examples of the same thing, just to be absolutely explicit there. So we're just outside our rule of 3 there. What's the pattern here? We're facing north, we face east. We're facing east, we face south, and south, west, and west, and north. I can imagine if we represented these directions as a list or an array, for example, just a simple string array would be, let's call it a compass. And, okay, we can just go northeast, southwest. So this is turning clockwise, north, east, south, and west. Okay. Now, if we wanted to know which way we're currently facing, index of. So what I'm thinking here is, if we know the index of the direction we're currently facing in our compass, then we can just add 1 to that index. So basically go to the next one in the compass. So not index. Like that. Now, that would work for north, east, and south, but for west, it's different. West has an index of 3. If we add 1 to that, we've gone over the edge. We're index out of bounds. So we want to go back to the beginning, go back to 0. So what we could do for the 4th one there, that's the pattern, I think, is add 1, but then mod 4. So we've got an array of length 4. So in other words, if you add 1 to 3, you get 4. The mod of 4 mod 4 is 0, so it takes us back to north. So I think that will work. Let's find out. Rerun our tests. And that is working. That seems to be the solution. Now, looking at this and then thinking about our left method, which I copied and pasted, and all I did was I changed some of the directions because we're not turning clockwise, we're turning anti-clockwise. So all that's different really between left and right is the direction of the compass, whether it's clockwise or anti-clockwise. So I'm going to bend the rule of 3 here a little because we've got 2 examples here, but I can see the pattern here. So I'm going to extract a method and I'm going to call that turn. And it turns in whatever direction we say the compass should turn it in. Let's run our tests. And let's inline that. Okay. Don't need a local variable. Remember Yagni, you ain't going to need it. Okay. Now that I've done that, I'm thinking actually I'm going to undo that. You'll see in a minute why I'm doing that. Let's just rerun our tests. There is a reason. There's a method for my madness, as we'll see. So I want to make this more. I could just inline that, but I want to describe what does that mean. And what it means is it wants you to turn clockwise. So let's rename that from compass to clockwise. Turn clockwise. So look for opportunities to make things describe what they mean or what they do. So that compass, northeast, southwest, means turn clockwise. Now that we've got that, we can reuse. So if we were to do a similar kind of thing for anti-clockwise, the northwest, southeast, the turning left. Okay. Turn anti-clockwise. There we go. So there you go. We've been introducing things that make the code hopefully more self-describing, easier to understand. And we've been removing duplication and using those opportunities also to make things easy to understand by introducing names that describe what these things mean. Now, and while we've been doing that the whole time, I've been rerunning the tests, making sure that it stays working. That's the most important thing. Don't break it. Now, finally, we need to think about whether this really is the simplest thing we could have done to pass the tests. And you may have noticed, let's just scroll up a bit, a little bit of code. So I've got this go method here that executes sequences of these instructions. And here's some code here for logging. Now, I'm thinking, we're being theoretical here. So imagine theoretically that nobody has asked for this. Now, you might be thinking, yeah, but the customer's not going to ask for logging. Well, that's only one customer. Remember, you have multiple customers, multiple perspectives that you need to approach requirements from. So you might have someone, for example, who works in operations or support who requires logging. So it's not just the end users you need to be thinking about. There are different kinds of users to your application. So the way I tend to approach this is I'm very, very strict about test-driven development. If I haven't got a customer and we've agreed a test, then they ain't going to get it. They should not expect to get it. And in this theoretical application here, in this theoretical situation, just imagine nobody has asked for this. I've just done it instinctively. I've just done it out of habit. So Yagni, you ain't going to need it. Nobody wants this. So what I'm going to do, just to prove a point, is I'm going to get rid of that line of code there. Oop, come on. And if I rerun my tests, provided, of course, that my tests are driven directly from things that customers have asked for, whether those are business end users or end users in the sense that we would know, or whether those are other kinds of users like operations and support people, for example. The process is the same. If I'm in charge of operations and I'm saying, okay, we need error logging, or we need logging to know for audit purposes or whatever the situation is, I wouldn't just expect the developers to fill in the gaps for me. I would write a little user story. I would say, as the operations manager, I need a log of all actions executed by users to be maintained for at least 24 hours so that we can easily recreate or debug or whatever or support customers in production or whatever the requirement is. And then that would get put in the backlog with everything else. Not that I don't like backlogs. That's another video for another day. But that will get scheduled like any other requirement. Developers would pick that up and say, okay, they're asking for this. We need to agree some tests with them as to what these logs need to contain and so on and so forth. So we don't put anything in our code unless somebody has asked for it. Essentially, it all costs money and it all adds complexity. Logging is just more code. And I have seen situations where the reason that the application was broken in production was because of logging. So it all adds to the cost and it all adds to the risk. So if nobody's asking for it, if you've got no customer tests that will fail, and we'll talk about customer tests in a later video, then you don't need it, basically. And just to prove the point there, I'll rerun the tests again. No tests are failing. We did not need that code. Now, I'm going to complete the process by removing the nlog config file here. We don't need that. So we're going to do a full delete of this, and then let's go on NuGet, and we can... Oh, I've already removed it. No, I haven't. Let's remove it. Let's get rid of that. So logging is gone, basically. Now, this is culturally and psychologically quite hard for developers to let go of things that they're used to just adding by default. For example, the number of times that I've worked on a project where we've got one requirement and it required 5 lines of code, and then you look at their Visual Studio solution or their Rider solution, and they've got the standard solution framework. There's a project for the tests, and there's a project for the web part, and there's a project for the business layer, and a project for the data layer. And I'm like, what data layer? There is no data layer. Why have you added these things? So you need to be quite hard on yourself and stop and ask constantly, is this really the simplest thing we could have done? Do we really need to do this to pass the tests? And we find that quite difficult. So it certainly takes some experience and some imagination, because sometimes the simplest thing is the hardest thing to see. It's much easier to do the complicated thing that we know how to do. But also we tend to find it hard to let go of solutions. Once we've got a solution in our mind, we kind of stick with it. So many developers, for example, have already added a database before we're even asked to store any data. Well, maybe we should defer that decision until we have a requirement that requires us to store data, and then make a decision about what database to use and how to use it based on the requirement, not on our idea of, well, yeah, obviously we add SQL Server. Well, no, not necessarily. Maybe a file will do it, you know. Maybe we don't need data storage at all. So Yagni, you ain't going to need it. So those are the 4 principles of simple design. Make sure that it works and keeps working, keep running those tests. Make sure that your code clearly communicates what it does. It clearly communicates its intent. So if you're looking at a block of code, for example, and thinking, well, what does that do? Maybe extract a method and use the name of the method to describe what that block of code does. That's what names are for. Look for duplication, partly because it increases the cost of changing code, but mostly because it provides clues as to where the abstractions need to come in. And that is a great way to discover a design in a very evidence-based way, because you're seeing multiple examples of where something is being used, where a single thing could be reused, and you're more likely to end up with the right abstraction when you've got multiple examples than if you try and figure the problem out up front and guess what the abstraction needs to be without seeing multiple examples. And then finally, Yagni, you ain't going to need it. And that's the hard one. Is this really the simplest thing we could have done? The kind of the rule that I go by here is there a requirement for this? Are there customer tests that will fail because it doesn't have this? And if the answer is no, it goes. And I do that partly because it's the best indication of whether or not it's really needed, but also because in my world, when I do software development, I want to train the customer. Customers do need training. I want to train the customer, and that includes potentially non-business customers, people, for example, in operations and support and training and other areas connected to our application. I want them to train them to expect that if we've not agreed tests for this, you ain't going to get it. It's as simple as that. And the best way to train them is to not add things speculatively, not to think, well, they're probably going to want one of these. Well, maybe not. Maybe we should find out. Maybe we should wait for a requirement. By all means, instigate that conversation. Have you thought about logging? But don't spend your customers' money on things they don't really need, basically. And don't forget, of course, that every piece of code, every line of code that makes it into your repository, that makes it into version control, is code that is going to cost 7 to 10 times as much to own as it did to write in the first place. So maybe it only took you an hour, but you just wasted a day of someone else's time downstream, and and hundreds of dollars or pounds or of your customers' money. So be brutal with yourself, be hard on yourself, and learn. Try to build the code. It can be really difficult because some people, some of us work with. I'm going to just say it. We work with some real arses who will give you a hard time for doing simple things. They will make fun of you and make out that you obviously don't know what you're doing because you haven't used all of the design patterns in patterns of enterprise application architecture. Don't feel the need to prove yourself. You can prove yourself in other ways. If you want to prove yourself on GitHub, prove yourself in other ways. The best way to prove yourself as a programmer is to deliver what the customer asked for. And as you start to build their trust that this is what they're asking for, and only the code that they're asking for, that you're not spending their money on gold plating your solutions, then that will help put you in good standing with the people you work with, and particularly with your customer. So there you go, principles of simple design. You apply this over and over and over again. So it sounds like, well, this is not a lot of principles. This all sounds very basic. But you'd be surprised at the kind of designs that can emerge, some very sophisticated designs that can emerge just by iteratively applying these organizing principles to our code over and over and over again. So there you go, simple design. I hope that's been of some use. Ring the bell for notifications, subscribe to this channel. In the next video, we're going to be looking at the principles of modular design.